Welcome to Nole Edge, the official podcast of the College of Arts and Sciences at Florida State University. I'm your host, Amy Walden, the Assistant Director of Visual and Social Media for the College of Arts and Sciences. And today we welcome Associate Professor Allison Wing and Assistant Professor Alyssa Atwood from the Department of Earth, Ocean, and Atmospheric Science here at Florida State. Welcome to the show.
Thank you so much.
Thanks, Amy. Thanks for having us.
So on today's episode, we're going to be focusing on hurricanes and the El Nino-Southern Oscillation, abbreviated as ENSO or ENSO, which is a scientific term for El Nino and La Nina. And many may know this as the warm and cool phases of sea surface temperatures and air pressure across the Pacific near the equator. With Florida State University's main campus being in North Florida, the study of extreme weather and hurricanes in particular is very pertinent to our lives here, where hurricane season determines a lot of how we live in the summer and autumn months. So before we dive into hurricanes and ENSO, I'd love for each of you to introduce yourselves and briefly describe your particular areas of study. Allison, we'll start with you.
Sure, thanks. So I'm Allison Wing, and I study tropical convection, tropical cyclones, and climate. And so basically, I study how cloud systems in the tropics, how they cluster together, the mechanisms by which they do so, how that influences climate and how it's affected by variability in climate, and how sometimes those systems of thunderstorms and clouds start spinning and turn into a hurricane. And so I study the basic physical processes by which hurricanes form and intensify, how they're affected by climate change, and how we can better model and predict them.
Excellent. And Alyssa?
Yeah, so I'm Alyssa Atwood. I am an assistant professor in the Earth, Ocean, Atmospheric Sciences department as well. And I am a paleoclimatologist, which means I study past climate change. And so really what I do is try to extend the instrumental record. We only have a few decades of really robust observations of the climate system. And so I use things called paleoclimate proxies, which are indirect measurements of the climate system to extend that record farther back in time. And so we can use all sorts of different geologic archives for that. There are things like tree rings and lake and marine sediments and ice that you might be more familiar with. For me specifically, I work largely on skeletons of old coral, and we can reconstruct things like temperature and ocean salinity from those things. We actually can get monthly records from certain parts of the tropical Pacific Ocean that we don't have a lot of data from. And so a lot of what we do is just trying to get more data from undersampled regions of the tropical Pacific Ocean and try to better understand climate variations and change and contextualize recent modern climate change.
Excellent. So Atlantic hurricane season runs June 1st to November 30th. And for someone who maybe only knows that a hurricane is a big storm, Allison, what would you tell them to kind of acquaint them with what a hurricane or tropical cyclone is, scientifically speaking?
Yeah. So a tropical cyclone is a rotating system of clouds and thunderstorms that has a low-level circulation that spins counterclockwise in the northern hemisphere up here. And these systems form over the tropical oceans, and they get their energy from fluxes of heat from the ocean to the atmosphere as seawater evaporates. That's sort of the fuel that powers and drives these storms. I'll mention also just in terms of terminology, tropical cyclone is the general word for that type of phenomena. In the Atlantic, we call them hurricanes. In the Pacific, they call them typhoons, but it's all the same thing, just using different words for the same phenomena.
Great. Yeah, that's great to clarify because I think a lot of people are like, what is a typhoon?
Yeah. I tend to use hurricane and tropical cyclone somewhat interchangeably.
Got it. So people in the Southeast may be less acquainted with the terms El Nino and La Nina, including yours truly as a lifetime Floridian. These are terms we just don't hear as often. So Alyssa, would you mind explaining the phenomenon of ENSO?
Yeah, sure. So the El Nino-Southern Oscillation, or ENSO, it's a cycle of natural climate variability that is has to do with a coupling between the atmosphere and the ocean in the tropical Pacific. And it's the source of the strongest year-to-year climate variability anywhere in the climate system on a global scale. And it generates environmental and societal impacts all around the globe, largely related to effects affecting temperature and rainfall patterns all around the globe, from South Africa to Asia to North America. So there are two phases of the ENSO cycle. There's the El Nino, which is the warm phase, and it's characterized by warming sea surface temperatures in the eastern equatorial, sort of the eastern half of the tropical Pacific. And there are associated changes in atmospheric circulation and wind patterns and stuff too. And then there's the cold phase, which is La Nina events, and it's characterized by cooling of the eastern equatorial Pacific and sort of strengthening of the Walker circulation and changes in winds and atmospheric circulation patterns. So, and then we have neutral conditions. Right now, just for a little context, we are entering a triple dip La Nina event, which means this is rare but not unprecedented, that this winter we're going into our third winter of having persistent La Nina conditions. And so, yeah, it's there are a couple there. We have sort of two different times we've seen that since we started making measurements in the 1950s. But yeah, it's a long time that we've been in La Nina conditions. And because of how sort of connected the ocean and atmosphere are, what happens in the tropical Pacific gets communicated all around the globe. And so things like changes in droughts and rainfall events and heat waves, and in North America, our weather patterns are most affected by ENSO due to the steering of the subtropical jet stream. So during El Nino or La Nina events, the position and strength of the subtropical jet stream changes, and that changes how storm tracks get steered into and across the U.S. And then the other big thing that we care about here in Florida is that ENSO impacts the activity of hurricane season.
And that brings us to our next question perfectly. So, Allison, can you tell us a little bit more about that and how ENSO affects hurricanes?
Yeah. So as Alyssa mentioned, these shifts in where you have warm and cool temperatures in the Pacific Ocean, that affects where you have the most rainfall and convection and clouds in the Pacific Ocean. And that has repercussions for wind patterns all across the world. And in particular, in El Nino, the warm phase, it's such that the wind patterns shift such that in the Atlantic, we have, in the Atlantic, we have less hurricane activity when it's in El Nino. So that happens because we have increased wind shear. So we have stronger, basically, over the tropical Atlantic, the winds high up in the atmosphere are from the west to the east, and the winds low down near the surface, the trade winds, are from the east to the west. And so when it's in El Nino, both of those winds strengthen. And so we have stronger, what we call vertical wind shear. And vertical wind shear is bad for hurricanes. So it makes them harder for them to form, harder for them to intensify. So we have quieter hurricane seasons in the Atlantic when it's an El Nino. And conversely, when it's a La Nina, we have a reduction in that wind shear, which provides better conditions, a more favorable environment for hurricanes to form. And so the El Nino La Nina cycle, ENSO variability is really the number one control on interannual variability in hurricane activity. It affects other parts of the world as well. So if it's an El Nino, the warm phase, there tend to be more tropical cyclones in the East Pacific, for example, and vice versa for La Nina. And so when we think about doing seasonal forecasts of hurricanes, so when they release these forecasts in, April or May or June and say, okay, it's going to be an above active year or an active year, a lot of that is based on what the predictions for ENSO are going to be that year. Mm-hmm. So for example, for this year, we had a La Nina last winter, and that was sort of predicted to either stay the case or maybe drift to neutral, but at least we did not expect it to go into an El Nino. And that, among other factors, led most outlets to predict that we would have an above active hurricane season this year. And so far, with, the exception of, unfortunately, Hurricane Ian and Hurricane Fiona just a week or two prior to it, that, has devastated parts of Florida. Other than that, it's been a very quiet season, actually. So it's sort of unexpected given what La Nina did. And it sort of speaks to the complexity of all the different factors that control hurricane activity. But El Nino is definitely a big one. And so it's one of these situations where a lot of our predictability on this sort of seasonal interannual timescale comes from that. But that's difficult because it's also hard to predict what El Nino is going to do on that timescale, especially when we're trying to make that forecast in the spring for what things will look like in the fall.
Yeah, that sounds a little tricky to me. So we know that weather happens on a massive scale. And one topic that gets brought up in every discussion is climate change and how things have changed over the course of the planet's history. So Alyssa, can you tell us a little bit about how ENSO has varied over time from hundreds of years ago to even millions of years? And what does this suggest about how it could possibly be changing in the future?
Yeah, so there's still a lot that we are learning about and understanding when it comes to both sort of the physics of the El Nino-Southern Oscillation and how the characteristics of El Nino and La Nina events are maybe changing both today and what we might expect in the future. When we look at the paleoclimate record, we see evidence for ENSO activity going all the way back to 3 million years. It's a pretty persistent feature. But understanding how and predicting how this mode of natural climate variability will intersect with, background warming in the climate system and anthropogenic climate change is still an open and very active area of research. So when we pair instrumental data and paleoclimate data together, the evidence shows that strong El Nino and La Nina events appear to have become more frequent and stronger since 1950 than they were in the centuries and millennia prior to that. But we still don't know whether that is fundamentally driven by a forcing by anthropogenic climate change, or whether that is just a function of natural variability and this rich spectrum of natural variability that exists in the climate system, especially in the tropical Pacific. So climate models are a really useful tool that we can use to try and parse out what is a forced signal and what is an unforced signal. The issue with climate models is that they have a hard time getting and the sort of basic features of ENSO right. There's a lot of developments, and every generation of climate model development projects that come out are making improvements, but we still have a ways to go there. And so there's some indication from climate model simulations that we might expect ENSO events to get more frequent and or stronger. And the same with La Nina events, actually. But I would say this is, again, still a pretty active area of research. And there are impacts of ENSO events, I think, that are more robust. So, especially the precipitation extremes associated, even if sea surface temperature, even if the basic features of the sea surface temperature anomalies don't change, we can still expect the precipitation extremes to get more extreme in the future under background warming of the climate system. It's a pretty fundamental aspect just of the physics of global warming. But the temperature anomalies and kind of the ocean components of that, of the ENSO cycle, are still we still have a lot to understand.
Yeah, and I think that's such an important thing to keep talking about, for sure. If there's one thing that you want listeners to take away from our discussions of hurricanes and ENSO today, what would it be? Allison, we're going to go ahead and start with you.
Yeah, I mean, I guess sort of reiterating something I said before, ENSO variability is the number one source of interannual variability in hurricane activity. And so, yeah, if we want to predict, what next year's hurricane season is going to look like, we need to be able to predict ENSO. And then, that contributes to, future projections as well. We've had various different types of both coupled climate models as well as statistical models, for decades working on predicting ENSO, but it still is a challenging problem. It's one of those things where I think once an El Nino or La Nina event gets started, then the predictions are quite good for how it will evolve. But there's something known as this spring predictability barrier, where things are sort of just in this in-between state in the spring, And it's hard to say what they're going to look like in the fall or winter. And unfortunately, that's exactly the time when we're wanting to be making our hurricane forecast. But I would just, use this season as a cautionary note that, while it is a big factor, it's not the only factor. And, even if we're in a La Nina and therefore expect an active season or vice versa, there can be other sorts of variability that compound the event. So, and then the final thing I'll leave you with is, regardless of whether we have a sort of forecast for an active hurricane season or an inactive one, as we saw, unfortunately, this year, even in a quiet season, it only takes one hurricane to have a devastating impact on you. And so for the, individuals out there thinking about preparing for hurricane season, you should take the same preparations regardless of what the seasonal forecast is.
Yeah, that's great advice. Alyssa, would you like to have any final thoughts on your takeaways?
Yeah, I guess I'll just say one more thing about, I don't want to leave you with the feeling that there's so much to learn still about ENSO that we have no hope for the future.
There's hope.
There's lots of hope. There's lots of hope. But just kind of coming back to, what the projections that we make for the future and what we can expect in the future. ENSO is this really incredibly important source of natural climate variability, but it's happening on this persistent and long-term warming in the climate system. And so, we still have a lot to understand about how global warming interacts with the ENSO cycle. But regardless, there's ample evidence that the impacts of ENSO are already being compounded by climate change, simply because those events are happening on top of warmer background conditions in the climate system. And so if extreme ENSO events become more extreme or more frequent in the future, which the jury is still out on, then those impacts will become even more severe, and we'll need to modify our projections. But the very last thing I want to say is that when we think about the risks of climate change, we really need to think about the impacts of on extreme events. And so whether we're talking about the ENSO cycle and droughts and floods, or heat waves, or hurricanes, or tropical cyclones, we need to keep a close eye on the projected impacts on these extreme events, including sort of the worst case scenario outcomes. And we need to understand how comfortable we are in sort of accepting the risks of those worst case scenarios. So.
Yeah. And if I maybe could just piggyback back on that, just regards to tropical cyclones specifically, driven by ENSO and as well as other sources, there are huge amounts of natural variability in tropical cyclone activity, but it is also being directly affected by this background warming that we see due to anthropogenic climate change. Our hurricanes are getting stronger and wetter, and sea level rise is causing there to be more flooding from storm surge, as we saw with Hurricane Ian. And so even though, there's variability driven by ENSO and otherwise, we have that backdrop. And I completely agree with Alyssa that even though there are other aspects of how hurricanes and other types of extreme weather events are being affected by climate change, even though there are other aspects of that are uncertain, there are these sort of high-end impacts that the strongest storms are getting stronger. And when they do occur, they can rain more, that we're confident of. And it does affect these worst case scenarios that we have to prepare for.
Yeah, that's a lot to think about. And that's a really important work that you guys are doing. Just want to say that in case no one had told you. So we end every podcast with our bowl of mystery questions. This is a little fun game we play at the end. So you guys can just, if you want to take one and you guys can both answer it.
What are the options for what these questions could be
Do we have veto power?
Yeah, they're harmless. Don't worry.
Okay. All right. If you could have one superpower, what would it be? Oh, gosh. I mean, I would like to actually be able to control the weather.
That's a great one.
My friends and family think I do. They certainly blame me when it's bad weather.
Oh, absolutely. It comes with the territory.
I would love it to just, still have hurricanes, but be able to just steer them all into the center of the ocean where they can just spin beautifully and not impact any humans.
That's a great answer.
I would like to do that.
All right, Alyssa.
you could have dinner with anyone from the past or the present, who would it be?
Well, I'm glad I didn't get that question.
That's a tough one.
That is a tough one. Well, Gilbert Walker, how about that? Who was fundamental in determining and identifying the Walker circulation, which is an absolutely critical part of ENSO. So, yeah, I would like to have a conversation with Gilbert Walker about how he identified. And, I do love science history and how people stitch together these theories of the climate system that come from such sparse observations. So it is.
Well, that was a fantastic answer, both of you. I'm sorry. You picked the two hardest questions in the bowl, I believe, but that's okay. You did great. So Associate Professor Allison Wing and Assistant Professor Alyssa Atwood, thank you so much for joining us on the podcast today. It's been a pleasure talking all about hurricanes, and of course, your respective areas of expertise. And if you'd like to learn more about Florida State University's Department of Earth, Ocean, and Atmospheric Science and the work that Allison Wing and Alyssa Atwood do, you can visit them online at eoas.fsu.edu. Thank you so much for listening, and we'll catch you next time on Nole Edge.